convergence of the subsequence and some examples. Clear? Now, I am telling the silent. Today I am telling the nice result about subsequence. The only result that is known as the Bolzano-Weierstrass theorem for sequence. It says every bounded sequence in R, obviously we are working on R, has a convergent subsequence. It means if you have a bounded sequence, so you can always say that it has a convergent sequence. The Bolzano-Weierstrass theorem gives the existence of a convergent sequence of a bounded sequence. For example, what can you say? Sequence, if you take a sequence sin n, this is bounded. So by Bolzano-Weierstrass theorem, so sin n has a convergent subsequence. But some students can say, sir, what is that sequence, subsequence? Please write that subsequence of sin n. Actually, sometimes you can write, but sometimes it is difficult to write explicitly that subsequence. Okay. Now, so don't ask, sir, what is that subsequence? This is writing that subsequence. It is very typical, but it is sure that it has a convergence sequence. Proof is not in your course. That's why I'm not doing that proof. Now, what is the use of this? If you see, every bounded sequence in R has a convergent subsequence. So can I say there are also sequences which has a convergent subsequence but not bounded? It means an unbounded sequence also have a convergent subsequence. If you are proving that a sequence has a convergent subsequence, so you cannot say that sequence is bounded. For example, suppose consider a sequence this an, this is equal to, I have done this example, this type of example in last lecture. This is, suppose you have this sequence. Now consider a sequence. Suppose this is, you can write A, 2, and just wait, don't speak. Any doubt? Aryan Gupta, mute your video. Aryan, आपका वीडियो ऑन है. An is equal to 1 by twice n. So what are the term of this? 1 by 2, 1 by 4, 1 by 6. So obviously A to n, clearly A to n is a subsequence of an and A to n converges to 0. So an has a convergent subsequence which converges to 0. However, an is not bounded. So it means you cannot say, if you find a convergent subsequence, you cannot say that that sequence will be the bounded. This is an example of this. Okay. So now this is the about Bolzano-Weierstrass. Now I tell you a new definition, Cauchy sequence. Cauchy sequence is definition. First I tell you a sequence. Suppose you have a sequence an in R is called a Cauchy sequence if for every epsilon is greater than 0, there exists a natural number n such that, what is it says? Am minus an is less than epsilon for all n m greater than equal to n naught. So what is the meaning of geometrically? It says for every epsilon is greater than 0. Yes, sir, in example 2, an is not bounded. Yeah, an is not bounded. Oh, sorry. This is my mistake. Yes, obviously. This is not clear. Aryan, bro, video is on. Yes. Yes, Vardhan. Sir, in example is not bounded. In above 2 is okay. Harshal, I have done. Okay now. So what is the meaning of this? Am minus an. What it says, for every epsilon is greater than 0, it means there exists a natural number n naught such that if you after n naught, the difference, the absolute difference of the two element is approximately approach to 0. It means negligible after some time. This is the Cauchy sequence. In convergence, what we do? If you here you write a l, so after some time the absolute difference of the term with its limit is negligible. Cauchy says the difference of two terms of the sequence is negligible after some time. If it happens, then it is called the Cauchy sequence. Karthike, just wait. Wait. Now, there is a theorem that is known as the Cauchy criteria. It says a sequence an is in R is convergent if and only if sequence an is Cauchy. I think, Karthik, you got your answer. Cauchy criteria says if you are able to prove that this is a Cauchy, so you can say this will be convergent. Or if you are able to prove that a given sequence is convergent, then you can say this is a Cauchy. So actually, when I started the sequence, so I told you my main aim is to check the convergence of a given sequence. So sometimes it is easy to prove that it is a Cauchy. From Cauchy, you can say that the given sequence is convergent. Here, Rakshit, AM, this is actually number two numbers greater than equal to an. Suppose you take n naught is equal to 24, so m and n both will be greater than 24. One can be 26, other can 28, या two consecutive number also. Yes, you can use Cauchy anytime. Karthike. Rakshit is okay?
Yeah, okay, sir. Thank you, sir.
Okay, okay. Now Cauchy trick right here. Now main problem occur one thing. By the definition, sometimes it is easy to prove Cauchy, but every time this is not easy to check from the definition that is it Cauchy or not. There are lot of questions. So sometimes it is typical. So now how you can check the Cauchy? So one scientist, actually Cauchy, gave a sufficient condition to prove that the given sequence is Cauchy, or that condition is very nice condition. From that condition, you can immediately within 2 or 3 lines you can say that the given sequence is Cauchy. So that is known as the contractive condition. The contractive condition statement I am writing, after that I will prove it also. Let An be a sequence of real numbers and alpha be a real number such that how 0 is less than alpha is less than 1 and mod an plus 1 minus an this is less than equal to alpha mod an minus 1 for all n element of n and n is greater than 2. Suppose you have a Cauchy sequence and alpha is a number like a 0 is less than equal to alpha and this condition an plus 1 minus an, then an is Cauchy. So if any sequence an satisfy these condition, then it will be Cauchy. So proof, so what you have to, how to you can prove? Example, you make the given sequence in this form or check alpha. If value of alpha lies between 0 to 1, so you can say this is a Cauchy. I will do one example. So first I want to do proof it. Because proof is important, then you can better understand what is actually happening. Let alpha element of R such that this is given and an plus 1 minus an alpha mod an minus 1 for all an element of n and n is greater than. Suppose you have a sequence an which satisfy this. Now you need to prove this is a Cauchy. So I will prove by definition only. I know this is a definition. I will prove by this. I will show that mod am minus an is less than epsilon for all n m greater than n. So up to here, if anybody has doubt, ask me.
सर
Yes.
यार अगर इधर अल्फा जीरो हो जाएगा तो जो लास्ट लाइन में लिखा हुआ है तो मॉड तो लेस देन जीरो हो जाएगा ना इधर
हाँ
तो मॉड तो लेस देन जीरो हो ही नहीं सकता
आपको एक रिजल्ट पता है? एनी पॉजिटिव क्वांटिटी विल बी विच इज लेस देन जीरो इज इक्वल टू जीरो.
यस यस यस
This
लेस
is
देन
equal.
इक्वल टू यस
Okay.
यस यस
Any other doubt? Yes, Vardhan. Alpha will be variable for given sequence. Yes, alpha is variable, but if it comes between 0 to 1, then you can say that this is a Cauchy sequence. If alpha comes greater than 1 or less than 0, you cannot say this is a Cauchy sequence. Yes, Vardhan. Yes, Vardhan, is it okay?
Yes, sir. Thank you, sir.
Now I proceed for the proof. Okay. Now, for suppose you have natural number. Now we have. I am driving a equation. First see that equation, then I will use this equation. An plus 1 minus a. You can write this is equal to alpha an minus 1. By using this condition, suppose this is 1. Okay. Now, here an minus 1, I am using again one condition. If you use this again, so this will be alpha an minus 1 minus an minus 2. So this will be an plus 1 minus an. This is alpha square an minus 1 minus an minus 2. Is it correct to all? Now, so if you repeat this thing, so here what I am writing, last will be here a1 and here will be a2. And this will be an plus 1 minus an. So what will be the power of alpha? Question is what will be the power of alpha? Idea is here see, here is 2. This is 2 or this is n minus 1. If you use power of 2 with this number n minus, so this will give you always n plus 1, which is this.
n minus 1, alpha की power n minus 1.
I know. Right, you are right. So this will be alpha n minus 1 because n minus 1 plus 2 will give you the n plus 1. This is an idea. Ayush Shukla, right? Now suppose this is 2. I will use this concept in next. Now, so for all I take m and natural number and suppose m is greater than n. 1 is greater than. Now we have. What we have? I need am minus an. So I can write because m is greater than m. This will be am minus 1 plus am minus 1 minus am minus 2 plus am minus 2 minus subtract my a minus 2 and add a minus 2 and so on. What will be last term? This will an, so what will be last an plus 1 minus an up to here. Apply the triangle inequality in iterative way. So you can write this is am minus am minus 1 plus am minus 1 minus am minus 2 plus this is plus, or this will be an plus 1 minus an. So now here I am using equation 2. So this am minus an, this will be, what will be the power here? A2 minus A1 for this am, sum will be 2. So this will be m minus 2 plus alpha, here will be m minus 3 A2 minus A1 plus here will be A2 minus A1, the power will be alpha n minus 1, I think. If anybody has doubt in the power of alpha, calculate. Okay. Now am minus an, this is less than equal to, take common mod A2 minus A1 from all A2 minus A1. Okay, this will be alpha m minus 2 plus alpha m minus 3 plus alpha n minus. Clear? So here am minus an, this is mod A2 minus A1. Here I am taking, this will be decreasing power. So alpha n I am taking comma, alpha ki power n minus 1. So there will be 1 power is decreasing. So I am writing from here 1, it will be a plus alpha square plus what will be this alpha m. So I think it will be alpha m minus n minus 1. Is it correct? It's visible. राहुल राज छोटा लिख रहा हूं क्या?
सही है सर, सही है.
Okay, Rakshit, I am telling how you are. Sir, please tell how you are getting power of alpha. In which expression, Rakshit? Last expression? Yeah, here this is.
The last third expression, mod am minus mod an is more than equal to.
Mod am minus 1.
Yeah, so last third line.
Last third this is. Here you can say am minus 1. So here A2 minus A1, if you use this expression, power of alpha and this 2 should be n plus 1. This will be this, n minus 1 plus 2, n plus 1. Now here same thing, 2 plus m minus 2, so m, that is power of this. Is it clear? I did the same thing.
Yes, sir, clear.
कैसे किया? ये तो प्रूफ कर दिया मैंने. आई एम यूजिंग इक्वेशन 2.
सर एक बार इक्वेशन 2 को भी एक्सप्लेन कर दीजिए.
इक्वेशन 2, this is I took an plus 1 minus alpha. I use equation 1 because sequence an follow this equation. This is given. So an plus 1 minus an alpha an. Now again apply equation 1, inequality equation 1 on this mod an minus 1. So it will be alpha, an will be decreased by 1, so it will be an minus 1, or decrease an minus 1, an minus 2, alpha square. If you do same thing, here will be what is, here I am doing one more time, alpha square into alpha an minus 2, an minus 3.
सर समझ गया, प्रोग्रेशन जो चल रहा है उसको आपने
Exactly.
nth टर्म के टर्म्स में लिख दिया, ठीक है।
और आइडिया, और व्हाट इज n minus 2 और 2, here the L3 alpha की power 3 plus n minus 2 n plus 1. If you add the power of alpha and this suffix in an, so it will give you this an plus 1, whatever with this.
सर
Yes.
सर ये
Yes.
जो इक्वेशन है उसमें लास्ट में an प्लस 1 माइनस an कैसे आया?
चिराग, आवाज नहीं आई आपकी, समझ में नहीं आई मुझे।
सर ये जो इक्वेशन है उसमें लास्ट में an प्लस 1 माइनस an कैसे आया?
ये यहाँ दिस इज इक्वेशन 2।
नहीं तो नीचे जो मेन इक्वेशन
अच्छा नीचे, अभी तो मैं यही डिस्कस कर रहा हूँ। आई एम कमिंग चिराग। ओके अप टू हियर सर। वो ए एन प्लस 1 कैसे आया आयुष? विच एन प्लस 1? ये दिस एन प्लस 1 दिस, ये तो जनरल टर्म के लिए मैं ले रहा हूं, किसी भी एन के लिए आयुष। एन प्लस 1 एन विल वेरी। आई एम ड्राइविंग एक्सप्रेशन फॉर जनरल। ओके आयुष, आयुष जैन।
सर वो जो आपने यहाँ पे लिखा हुआ है ना an प्लस 1 माइनस an,
हाँ
सर वो वाला an प्लस 1 कैसे आया सर? माइनस an तो आ गया, am माइनस an वाला an है ये।
अरे यार देखो, इसका मतलब क्या है, आप जब भी n की वैल्यू 4 लोगे तो मैं क्या कर रहा हूं, a5 माइनस a4 सब्ट्रैक्ट कर रहा हूं। दो कौन से क्योंकि n नेचुरल नंबर है, सारे टर्म्स तो हैं सीक्वेंस में। सारे टर्म्स आर अवेलेबल इनफाइनाइट, a1 a2 a3। consecutive number, and I am writing this expression. Just okay. Now, am I audible?
यस सर।
Yes, sir.
Yes, sir.
यस सर।
Now, again, I am speaking one by one. This is just wait. Who were asking the just first voice lagging? Okay. It is A1 sequence can be written A1, A2, A3 up to AN infinite, because n is a natural number. So whatever you take n, it is up to you. So I am taking the absolute value of two consecutive number. So it means I am trying to express I am trying to drive a general expression of the difference of two number in terms of a2 minus a1 by using the given condition. भाई टर्म्स क्या होंगे, a1 a2, कहीं an होगा, फिर इसके बाद an प्लस 1 an प्लस 2, ऐसे होंगे ना टर्म। क्लियर? Who were asking the question this? Clear or not?
Yes, sir.
Okay. Now I am coming to last this. Here, what I am saying, this power is in decreasing order. So here I am taking alpha ki power n minus 1 common. So here one power is decreasing. If you take alpha ki power, so this will be 1. So here I am writing 1. Second term will be here. If you have, this will be plus alpha n minus 2. So alpha square. Now alpha की power m minus 2, if you take alpha की power n minus 1 common, तो दिस विल बी अल्फा की पावर m माइनस n माइनस 1. Is it clear? One student was asking me, sir, how it expression comes.
Yes,
Is it clear?
Yes, sir.
Okay. Now am minus an, this is mod a2 minus a1 alpha n minus 1. Here 1 plus alpha, alpha square alpha, how many terms are? M minus n. This is a GP with common ratio alpha. So can write this 1 minus alpha m minus n over 1 minus alpha. Since this is GP, geometric progression with common ratio alpha. Now, can I write this? If anybody has doubt, ask me. Am minus an is less than mod a2 minus a1 into alpha n minus 1 over 1 minus alpha. Suppose this is 2 or 3, whatever with the just wait, 3. This is 3. If anybody has doubt, ask me. Because alpha m minus 1, this is a positive quantity. So you are subtracting positive quantity. So this will be less than. Here you can write this is less than. Is it clear or not? If anybody has doubt, me ask me. Clear? Alpha
Sir,
is positive.
please.
Yes.
Sir, please repeat.
What I am saying, you can write. I use this concept. 1 minus alpha. I am writing here. 1 minus alpha n minus 1. 1 minus alpha. This you can write 1 over 1 minus alpha n minus 1 over 1 minus alpha. So this is positive. This is positive. If you subtract
Yes, sir.
positive, so this will be 1 upon 1 minus alpha. So here I am writing here due to this 1 upon 1 minus alpha multiply alpha की power n minus 1. Now equation 3. Any doubt now?
सर मतलब आपने कहा कि अल्फा टू द अल्फा रेज़ टू द पावर m minus 1 is lesser than 1 ऐसा.
क्या? I am saying this expression will be less than 1. This expression 1 minus alpha की power m minus 1 will be less than 1. इस expression को लिख. Okay. I am doing more. Just wait. Mod am minus an. Can you write in this way? Mod a2 minus a1 over 1 minus alpha into alpha n minus 1 minus mod a2 minus a1 over 1 minus alpha into alpha की power m minus 1.
1.
Now this is positive. A2 minus 1, 1 minus alpha, this is positive or 0. So this will be, can I write in this way? Mod A2 minus A1 alpha n minus 1 over 1 minus. I think there should not be any confusion now.
सर वो पॉजिटिव होने से नेग्लेक्ट कैसे हुआ ये समझ नहीं आ रहा. मतलब पॉजिटिव होने से नेग्लेक्ट
भैया अगर पॉजिटिव चलो कोई नंबर है 5, अगर इसमें से पॉजिटिव घटाओगे तो 5 से तो कम ही होगा भैया. अगर नेगेटिव घटा दोगे तो ये पॉजिटिव 5 माइनस अगर -1 घटा दोगे तो 6 नहीं हो जाएगा.
हाँ
तो 6 क्या 5 से कम होता है?
नहीं.
5 में से अगर पॉजिटिव टर्म घटाओगे तो इट विल बी ऑलवेज लेस देन दिस नंबर.
अच्छा हाँ ठीक है समझ गया. हाँ
ओके नाउ म्यूट अर्जुन. So now, case first. There is chances if A2 is equal to A2 minus A1 is equal to 0. Just wait, 1 minute, just hold on. A2 minus A1. A2 minus A1 is equal to, that is A2 is equal to A1 ho, it may be a chance. If two number, there may be chance that two number of any sequence are same. It means what will be mod AM minus AN will be 0 because equality. So you can write AM is equal to AN for all n, but n can be 1. So can I write AM will be A1 for all n. So it means sequence AN will be constant sequence. Is constant sequence. If it is a constant, so every constant sequence converges. Hence, it is Cauchy. First part is over. If A2 is equal to A1. Any doubt? Now, second. Second is a little bit tricky. If A2 is not equal to A1. Okay. Now what I am saying, see this expression alpha raised to power n minus 1. So can I say alpha, this is a sequence, alpha n minus 1, this sequence will converge to 0 since 0 is less than alpha is less than 1. This converges to 0. This is a GP which converges to 0. So it means if this converges to 0, let epsilon is greater than 0 be given. You take any positive number. Now why I am taking a expression, because to bring the expression in terms of AM minus AN less than epsilon. What I am saying, epsilon is greater than 0. For I consider another positive number epsilon 1. How it is designed? Epsilon 1 minus A over mod A2 minus A1. Why? In 3 you write alpha a mod A2 minus A1 upon 1 minus alpha. I will keep value of alpha ki power n minus 1 and it will be cancelled out, and term will come in the form of epsilon. So if this is a, just wait, if this is a convergent sequence converges to 0, so definition of convergence will also be true for this number, for every positive number epsilon 1. This number, so there exists, you can write a natural number and not such that this alpha n minus 1 minus 0 less than epsilon 1, which is equal to epsilon 1 minus A mod A2 minus A1 will be for all n is greater than n naught. Now, if anybody has confusion, I can write one more term. Don't confuse. You can write n minus 1 is greater than n naught. So n is greater than n naught plus 1. You can consider suppose this is 1. So same thing, because you need a integer. So don't confuse, there are same thing. There will be no problem in the question. So here, this will be alpha n minus, this is positive. So you can cancel out, yeah, you can write. This is epsilon 1 minus a over a2 minus a1 for all n is greater than n1. Suppose this is 4. N1 I am using because if you have any doubt, you can use in this way. Now, here see equation 4 using in equation number 3. Put the value of alpha ki power n minus 1. So what will be? Mod am minus an. This is less than, what is you have? A2 minus A1 over 1 minus alpha. Here is alpha ki power n minus 1. Put value 1 minus A over mod A2 minus A1. What is n is greater than or equal to? So m is greater than n is greater than n1. If you cancel out, so this is mod am minus an is less than equal to, is less than, sorry, this will be less than, this will be less than epsilon for all m and greater than n naught. So this is a, so sequence you can say is Cauchy. So one more thing, again I am telling this expression. Idea is why I write epsilon, because I show you here is epsilon, because you can, because a nice expression comes, you will have no confusion. That's why I multiply by epsilon. So convergence of alpha ki power n minus 1 must also hold for epsilon 1. Mod 1. I take mod 1 minus a by mod a2 minus 1. Idea is this, because I want to cancel this expression and bring you the expression in terms of epsilon. So this is the Cauchy. Now I am doing one example, how you can check that this is a Cauchy or not. So this is a nice example.
Sir,
Yes,
सर केस 2 समझ नहीं आया सर.
I am explaining again. Okay. Case 2 is if A2 is not equal to A1. Now we know that alpha ki power n minus 1, because it is in equation number 3. This will converge. You have a geometric expression and alpha lie between 0 to 1. So this will converge to 0. Clear? Now I am using the definition of the convergence. So definition kya hai? For any positive number, there exists a natural number n naught. So what I say, I epsilon greater than पे positive number लिया, लेकिन I am applying definition for epsilon 1. Epsilon 1 I took epsilon 1 minus a mod a2 minus 1, because if you put epsilon 1 in the expression, then 1 minus a mod 1 minus a by mod a2 minus 1 will be cancel out and term will look like in terms of epsilon. So here there exists a n naught, by definition alpha ki power n minus 1 minus 0 less than epsilon. This is some student can say sir आप लिख रहे हो n is greater than n naught, but वो तो a n minus a naught के लिए था. So n minus 1 there is no problem. N minus 1, if you write n naught, so n is greater than n naught plus 1, you can take n1. So there is no problem, term will always exist. So you can write n is greater than n1. Yeah, here you can directly write n is greater than n0. Yeah. So now I use this value of alpha ki power n minus 1 in 3. If you put this is mod a2 minus 1 and n is greater than n, I have taken, or n is greater than n1. n1, sorry, this will be n1. So here you have mod am minus an less than epsilon. There exists a integer n1 such that m is greater than n. So here this is the definition of Cauchy, convergence of the Cauchy. Is it clear?
सर
Yes.
सर वो मॉड 1 माइनस ए 1 माइनस अल्फा होना चाहिए ना
एक 1 minus a.
1 माइनस अल्फा होना चाहिए ना
Oh, sorry,
तभी वो
sorry. Yeah. This is my mistake. You are right. ये भी वही होगा. मैंने गलती से लिख दिया ये. I am doing correction. This is alpha because I want to divide. The idea is this. Alpha. Yes, any doubt? Now let us do one example. Yes.
सर एप्सिलॉन 1 की वैल्यू कैसे आई?
एप्सिलॉन 1 की मैंने बता दिया बेटा. एप्सिलॉन 1 की वैल्यू ली हमने. एप्सिलॉन मल्टीप्लाई एप्सिलॉन और दिस नंबर. इट मीन रिवर्स ऑफ दिस नंबर. जो ये नंबर है mod a2 minus a1 by 1 minus alpha. Of this. So that अगर हम वैल्यू रखेंगे एप्सिलॉन वैल्यू अल्फा की पावर n minus 1 रखेंगे तो ये विल बी कैंसिल आउट पर एप्सिलॉन विल बी रिमेनिंग. Any other doubt? Suppose you have this xn plus 1 is equal to 1 upon 2 plus xn. Now question is sequence xn converges? Now, one important thing, this is a recursive sequence. You can prove by monotonic increasing or decreasing or bounded. Then you can also prove that this is a convergent sequence. But if you prove this sequence by using monotonic, increasing or decreasing and bounded, so it takes time. Sometimes it is very typical that ये increasing हो ही ना, decreasing हो ही ना. It may be. It depends upon sequence. If you use this sequence Cauchy criteria, you can prove within 1 minute. You can see. Take xn plus 1 minus xn. Here xn, this is equal to an. So what will be xn plus 1? 1 upon 2 plus xn minus 1 upon 2 plus xn minus 1. This will be mod xn minus 1 minus xn 2 plus xn 2 plus xn. Mod xn plus 1 minus xn. This is. You can take common minus 1. So this is same. No problem. Mod 2 plus xn 2 plus xn. So here can I write this mod xn plus 1 minus xn, just wait. Yes.
So I think it is 2 plus xn minus 1.
xn minus 1 होगा in denominator.
So in the denominator.
सर डिनोमिनेटर में एक xn minus 1 होगा.
कौन से इसमें थर्ड सेकंड फर्स्ट
सर डिनोमिनेटर
Second और
सेकंड
सर सॉल्यूशन का सेकंड लाइन.
ओके या दिस ऐसे में दिस इज ट्रिवियल, तो जल्दीबाजी में ये थोड़ा, दिस इज एक्स एन माइनस वन, करेक्ट। तो नाउ mod 2 plus x, can I write 1 by 2 into 2 mod xn minus 1? Because 1 upon mod 2 plus xn will be less than equal to, will be less than 1 by 2. Because xn all are positive. All are positive, x1 is equal to 1. So here you have mod xn plus 1 minus xn less than equal to 1 by 4 xn minus 1. This, if anybody has down, you can remove inequality also, because either or condition. So alpha is equal to 1 by 4. So you can say sequence xn is Cauchy. Hence, if it is a Cauchy, hence it is convergent. Because a sequence is Cauchy if and only if it is a convergent. Suppose xn converges to L. So that is, you can write limit n is tend to infinity xn is equal to L. Now xn plus 1, I think this is 1 upon 2 plus xn. Taking limit of both sides, as n is tend to infinity. So this is limit n is tend to infinity xn plus 1, limit n is tend to infinity 1 upon 2 plus xn. Or here obviously this is L over 1 upon 2 plus L. If you simplify, L is coming, do yourself, this is will coming, I think L to, yeah, you can write this is, this will be L square plus twice L minus 1. Apply सीधी तरह formula. So this is coming minus 1 plus root 2 or minus 1 minus root 2. This cannot be. So limit at least tend to infinity xn is coming minus 1 plus. So this is the today lecture. If anybody has doubt me, otherwise today lecture is over.